Hey, this is TJ from smokescreendesign.com, and I wanted to discuss this topic about, do buildings lean, do objects lean, can we see it? Because this is really a big thing for the flat earth versus globe earth discussion that comes up a lot. And it seems to make sense that if you're going over a curve that things should lean away and we should be able to see that. But looking into this further, it seems to be something that is not going to be that noticeable, and I want to show you some examples of that. And I'm going to come back to this picture since this is a real picture we get to look at instead of like animations and cartoon drawings, that kind of stuff. Now, the Earth's circumference is supposed to be 24,901 miles, and a circle is 360 degrees. So we want to determine the degree of change between two objects. So if we divide the circumference by 360 degrees for a circle, then we come out with 69.1694444 miles. So that's why a lot of people just go with 69 miles. So for every 69 miles, there's 1 degree of change. So when we are debating with the globe, then that's what we go off of. Or if we're trying to compare a globe with a flat earth, how things should look, should things lean away, that's what we go off of. Unless someone can show me different. Now this here, many of us are familiar with. Let me go out further. We have this by M. Kanki. I'm sorry, I wish I knew your name so I could pronounce it right. So he created this, a precise measurements from AutoCAD, and see what the drop in curve would be, and see a little closer what drop in curve would look like. But let me see how close I need to get. I want to get a lot closer than that. When we look out here, we see one for 10 times magnification of that above, and this is what curve would look like over 120 miles. And you'd see we'd have to be pretty far out to see this type of distance. I mean, up and close it would look different. Now, one thing I wanted to do was to show this is a starting point, this is 0, and then here's 70. So I just moved over a little bit. We see the curve. I took this line and I made this line 1 degree to the right. So it would lean away 1 degree from this. Let's say this is a building, 1 degree from here. Now 69 miles to try to look at is a huge distance, very huge. And then approximately this line out here would be 120 degrees. Since it stopped at 100, this is probably about 10 somewhere in here, and probably about another 20 here. So 120. And I made this one lean 2 degrees. So it really should be about 140 for 2 degrees, but just go 120, made it 2 degrees. Now if you look at each of these, this one's a 90 degree. That's right on. And hold on, I got this thing in here. Go away. That's because I need that right there. And then this one was a 90 degree, and then I just used the free transform tool and I changed it by 1 degree to lean. And you can see it deviates a little bit from that line. Now if you also think about these lines here would be equivalent to about 10 miles if you're looking at it to scale, maybe a little more than 10 miles. So to really notice this change, I mean, these lines have to be pretty huge compared to this scale model. And then we've got a 90-degree line right here, but we can see that again this is 10, 15-mile line based on the scale that we see here, and that's when we really start to see the change. Below that, you don't really notice it. Again, this is just going off of that model that we had there. So this here, a friend of mine shared this picture. It was taken by John Ashworth. Hopefully he doesn't mind that I use this. And this is looking at a power plant. And this is over in, I believe it's the UK, Snowdonia or something like that is somewhere out here. Wales is somewhere out here. And you can see all these mountains in the background. Now, this power plant here is approximately 32 miles away, maybe 36 miles away. Now, for 32, 36, we're pretty close to looking at a half degree of change. So what I did is I drew some lines out here. I wanted you to look at it from a distance first. I drew some lines out here, drew two perpendicular lines. There's the green one and the white one. The white one, I tilted that 1 degree. Remember, it would only be half a degree, but I tilt that 1 degree to the right. Now, from this distance, can you tell me that you can tell that that white line is 1 degree to the right? I mean, looking at it, like, yeah, not so much. I mean, even put this straight edge right next to it, I don't see that that's tilted. So that's why I've been rethinking that we're not going to really be able to see. I mean, people are saying we should be able to lean back. So this should be leaning back 1 degree. Sorry, 1/2 degree if it was on a curve. If we can't see a building that is leaning to the right, which this is simulating, 1 degree, how are we going to see a building that's going to lean back a half degree, leaning back 1 degree? Now, if I zoom in, right, so if we get really close on an object, we might be able to notice that. We might. And I'll even show you how. I'm going to try. For some reason, as soon as I wanted to do this, never had this problem before. Just this line tool is just acting up. It's not even, I don't know what the deal is. Never had this problem before. Alright, so that is 90 degrees. That's on this guideline here, straight, perpendicular. Stupid tool. Now what I can do is I can change that. You're not going to see me change it, the number I'm using. Let's see, free transform. Now let's change it to 45. So you can see there's 45. Let's change it to 1. Change it to 0. 2. You can see slight tilt with 2. 1. Back up. 2. 45. 0. 1. You can barely see a movement in there for 1. No, can I do half? I should be able to do half. Half degree. That's even. I just set it to 2 because I want you to see 2. 2 degrees. It's tilted 2 degrees. And you can't even tell that it's tilted. Now remember, this is not a 3D world, so to speak, that I'm in right now. So I don't know how to get that shape to go back any degrees, but it would be easier to detect if it's going from side to side for the tilt. Now let's take a look at this one. I worked on this yesterday, or made a video on this, and I wanted to just take this section out, talking about buildings leaning. Let me see, let me try to go in further. So this is the Fried Canyon, Utah area. I did a video on this, you can check that out, and all these measurements. Here we have, in the back, we have Mount Ellen Peak, and this is, like I said, in Utah. Is this one in Utah? Because I think this whole area that I did span like 3 states, Colorado, Utah, and Arizona. So Mount Ellen might be in Arizona. Approximately from the base to the peak of this one, this is Mount Pinnell. From the base is about 6,000 to the peak is about 11,400 feet. So we are looking at 6,000. Sorry, we're looking at about 5,400 feet difference from the base to the peak. So it's almost a mile high from the base. And you think about that, just, we throw around measurements, whatever. Like this right here is a mile. We are approximately looking at 1,475 feet. They said that's how high the balloon got. I'm assuming that we are at the peak of that. This is meters. So approximately we're 19 miles high, and this is a mile. So at this height, I mean, distance, a mile is quite insignificant, very small. Now over here, let me tell you this distance approximately in this area here, where this red line is, come up a little further, between there and over here is 150 miles. Alright, so we want to use a 2 degree of change between this mount and this one, approximately 120 miles. So it really should be less than 2, but just for effect we're going to use 2. So if this was a curve, then we should see this peak and this peak. We should see them, one should lean away from the other 2 degrees. So we've got that appears to be 90. I mean, even this one appears to be 90. So I drew this line here same way, gave it a 2 degree of change. Now this is Pastora Peak, and it's about 9,400 feet. The base is somewhere around 6,000, maybe 6,100, in that arena, depending on the area we're looking at. So between the base and the peak, we're looking at about 3,400 feet, so not near a mile. Now this white one appears to have maybe a little bit of slant to it, but keep in mind where we see the slant, it's in the height. So this is way above the peak. It's possible that these lines are a mile high. So remember, this line here is about a mile high from the base to the peak. So these could be approximately about a mile high. So that's when we start to see, maybe some change here from this distance, but only because I'm drawing it out and because it's a mile high. So think about a building that's 100 feet. I mean, we're talking about this approximately being 5,000 feet, a little over 5,000 feet. So we're looking at buildings that might be something like this. So at this height, will we even be able to see a degree of change, 2 degrees of change from this location to this one if it were buildings? I mean, think about buildings that high. I mean, think about buildings this high comparing the two. I don't think so. Now, it is possible that we could get this camera to go lower, be closer, because we won't need all this extra space. We'll need all this extra space. So maybe there's camera footage that could show it lower and bring it closer. But we're looking at objects that would be so tiny that unless these buildings are a mile high, maybe even 2,000 feet high, means unless they're really tall, we're not going to really notice anything. If we get really good shots, maybe we can go in with straight edges and kind of see what's going on to compare that and see if there is any sort of change. But if this was the building you were looking at, would you be able to tell if there was a change? I mean, look at the space between just this turquoise line, this white line, and this on the side. You've got this little space right in here. Would you be able to see 2 degrees of change? No, we see it up top. You can see it there. Let's come over here. So to really see something, and this is just going off of this experiment, not saying that it's absolutely conclusive, but to be able to see something with a change like this, I mean, we have to have extremely tall objects. Like I said, we're looking at a mile here to be able to see the change up top. So to say that we should see boats, buildings lean away from each other, from what I'm seeing here and what I'm looking at, they have to be some really tall buildings, really tall boats, objects in a distance away from each other to really try and determine that. And think about, let's say, a halfway point. Let me try to see here, just an approximate. So let's draw another line. And why do you not want me to draw? Oh, put a new layer in here. Oh, come on. This thing is just really bugging me. Didn't even know if it drew a line. Oh, it did. So let's do 1 degree. Went halfway. I'm going to do 1 degree. Just make sure it's moving, because there's 45. There's 2. Yep, so we moved it to 0, goes back. 2, we see it move. 0 goes back. 1 degree barely moves. So let's get in here, get closer again. This is our 1 degree of change. Stop sticking. Remember, this distance is pretty high. It's pretty high up there. based on this model. I mean, that could be a mile, easy. Alright, so we do 1 degree, 45. I've already changed it to 1 degree, so it should have a 1 degree tilt. Which, if I change it to 1 degree again, it's not even noticeable. 1 degree. So that's just something I've been thinking about now. Something I wanted to do a video on. I haven't seen anyone do a video about the degree of change, about being able to see objects at tilt away, and if there's something that I've done wrong here, please definitely let me know, because yeah, this seems to me that we've got to stop saying that buildings are going to lean away. I know I'm not going to be famous for all my sort of debunking, correcting. Um, may even make some people hate me because they say mean things about me, and because oh, you can't be in a flat earth because you're disproving things. Well, this is about the search for truth and the earth that we live on, and if we're going to be on this journey for truth in the earth we live on, then we need to have factual information and tell the truth. So, like to hear from you, see what you got to say in the comments. There's, I mean, if I'm right on, or if there are any corrections, and didn't use the artist rendition, which is usually something like this. Let me put a new layer in here. Here's the artist rendition. Well, you got Joe. Joe's standing here, and then he's looking at a boat that is out here. You see how that leans away? Or how about this one? See how that boat leans away, or that building? He should see that. Well, you know, the artist rendition that's extremely exaggerated, because you can see we're at 1,000 miles. About 1,000. These are probably 100 miles each. So 10, 9, 8, 7, 6, 5, 4. So right here we're at 400 miles. So that's something I didn't want to do, because I see a lot of that exaggeration. Anyway, like to hear from you.